Today, this is the goal of string theory: to unify our understanding of everything, from the birth of the universe to the majestic swirl of galaxies, in just one set of principles, one master equation. Newton had unified the heavens and the earth in the theory of gravity. Maxwell had unified electricity and magnetism. Einstein reasoned all that remained to build a theory of everything, a single theory that could encompass all the laws of the universe, was to merge his new picture of gravity with electromagnetism.
He certainly had motivation. Probably one of them might have been aesthetics or this quest to simplify. Another one might have been just the physical fact that it seems like the speed of gravity is equal to the speed of light. So if they both go at the same speed, then maybe that's an indication of some underlying symmetry.
But as Einstein began trying to unite gravity and electromagnetism, he would find that the difference in strength between these two forces would outweigh their similarities. Let me show you what I mean. We tend to think that gravity is a powerful force. After all, it's the force that right now is anchoring me to this ledge. But compared to electromagnetism, it's actually terribly feeble. In fact, there's a simple little test to show this. Imagine that I was to leap from this rather tall building. Actually, let's not just imagine it. Let's do it. You'll see what I mean. Now, of course, I really should have been flattened, but the important question is, what kept me from crashing through the sidewalk and hurtling right down to the center of the earth? Well, strange as it sounds, the answer is electromagnetism. Everything we can see, from you and me to the sidewalk, is made of tiny bits of matter called atoms. And the outer shell of every atom contains a negative electrical charge. So when my atoms collide with the atoms in the cement, these electrical charges repel each other with such strength that just a little piece of sidewalk can resist the entire Earth's gravity and stop me from falling. In fact, the electromagnetic force is billions and billions of times stronger than gravity.
That seems a little strange because gravity keeps our feet to the ground, it keeps the Earth going around the sun. But in actual fact, it manages to do that only because it acts on huge, enormous conglomerates of matter. You know, you, me, the Earth, the sun. But really at the level of individual atoms, gravity is a really incredibly feeble, tiny force.
It would be an uphill battle for Einstein to unify these two forces of wildly different strengths. And to make matters worse, barely had he begun before sweeping changes in the world of physics would leave him behind.
Einstein had achieved so much in the years up to about 1920 that he naturally expected that he could go on by playing the same theoretical games and go on achieving great things. And he couldn't. Nature revealed itself in other ways in the 1920s and 1930s, and the particular tricks and tools that Einstein had at his disposal that had been so fabulously successful just weren't applicable anymore.